Hi guys, my name is Boris and I'm a computer engineering bachelor student at the Technical University of Berlin. And on this channel I want to talk about things that I have learned and might bring you value, general educational topics and lifestyle ones. Today I will walk you through the actual code of our network protocol programming lab, and you will here see how such a code can look like, learn a few tips and tricks, and see how the volume of such a project can possibly look like, and some key elements of working so close to hardware. Now, this is part 2, and I really recommend watching part 1. I will link it up in the info card above, so that you have a better understanding of the concept of our project. But with that said, let's get to the code. So, let's start with the low-level communication that we have. As mentioned, we are working with a CC1200. And basically said, with that CC1200 there is a library that comes with it, with which we can directly write into the registers. So we enter a address value and then we enter the value that we want to write into that register. And working with registers can be quite intimidating because there are a lot and all of them are defined here, and you see there are a lot and all of them have a specific functionality. And when we initialize our board, we want to write all of the correct values into the specific registers. But all of them are basically always the same, and if you want to change a specific register that has a specific functionality, you will do that in the process where you are developing an idea and think, okay, how can the board assist it? And then you'll look up the register that will help you with that. Other than that, it's just pretty a straightforward thing. So, and yeah, that's basically everything that this initialize function does. It just writes some registers and at the end it enters the receiving mode. And this is the important thing to know. This board has two very important modes, and those are the receive mode and the transmit mode. And as the name suggests, you can't transmit in the receive mode and you can't receive in the transmit mode. The RX stands for the receive mode and TX would be for the transmit mode. So with that out of the way, let's take a look at this receive packets variable function. Now, this is more or less the heart of the protocol. This is the function that handles all the different message types. Yeah, so we will not look at that quite now. We will first look at this function decode message. And to understand decode message, let's take a look at our frame structure that we have defined. Our data frame consists of the packet length, and this is actually necessary and determined by the board that we need this packet length as our first byte. And this is basically just the size of the payload. So let's say we have a message that is 3 byte long and plus the 3 other bytes here, address, metadata, and source. And address, pretty self-explanatory, the target address to whom the message is addressed. Then metadata is really important. Metadata defines what type of message it is. And then we have our source, which is the ID of the node that is sending out this message, and yeah, the actual payload if we have any data to transmit. And here we can already see the different types of messages that we have. I have already talked about the mule to mod communication, where we would send out a search message, then we would answer with a found or discovered message, and then we have our data messages, which are being acknowledged with a acknowledge message. So that should look a bit familiar. So now that we know how our data frame is basically structured, let's take a look how we actually decode the message that we receive. So we have our FIFO, and this FIFO is really fundamental, and this is again just a address from which we will just always read 1 byte. This reg read pops 1 byte from this FIFO. And we know how our data frame is being sent out, so we know that our first byte that we can read out is the packet length, then the address, and so on. And here we will just pick out the message itself from the payload, and so on. And we have this data frame that we will just add all the values to that we are reading out, and then in the end we will return this packet. And this little if statement here is to check the CFC sum again, and if the CFC is wrong, so the packet somehow is corrupted, a byte was flipped or something like that, we will create another answer frame that is of the message type false CRC. And this false CRC message type just requests from the sending or transmitting node to resend this packet. And this happens here. We construct our data frame until here, then we send our data frame, and we change back to receive mode, and we wait for reception. Now let's take a look at this send frame function, because this one is again very important, and it is a abstraction function. We don't have to write every single byte into the FIFO with this function, so we just pass the frame that we want to send out, and this will do the work for us. And the way the board works is you enter the transmit mode, and then you just write every byte that you want to transmit into the FIFO, and it will automatically be sent out. So that's this send frame function. So then we have this wait for reception function, and as the name suggests, we wait until we have a byte in our FIFO, so we have received another packet. And if that's the case, we will jump back up to our while loop and we'll see, okay, our CRC was wrong. So we will again loop through the same process, and we'll again receive our packet that has been resent and fill up our load data frame that we'll then return. And again, when then the CRC is finally correct, we will then be able to just break out of the loop because the CRC is correct, and we'll then just return the data frame. So those are the basic functionalities that you have to know. How to receive a packet, so how to read from the FIFO and how this actually works, and that it just works like that in the receive mode, and how to send out a data frame, which is basically the same, just writing into the FIFO and being in the transmit mode. So before we go into depth into this receive packets variable function, let's first go into our main. So in our main, there is quite a bit of stuff happening here. So in the beginning, there's a bit of handling, and we can enter some arguments to determine if our node is a mule or a mod, and then we can enter the ID of the node that we want to run. And then we have this archive thing here. And this is really important. I don't quite remember if I talked about the backpack, but every mule that we run on a node has a backpack, as we call it, which is just a list of an array of lists. And every index of the array corresponds to a mod. So we can add messages to a specific mod. And every time we want to send out a message to a mod, this message will be deleted from our backpack. But the thing is, we'll get to that in a bit. We also want to know what messages have been sent out. And that's what the archive is for. And the archive is a hash table in our case. And where the key is just the node ID with the message in a specific string format. And yeah, that will just be added into the hash table. And we know that this will be a message that has already been sent out. So I think I'm going a bit too deep into all of this. Here we initialize the backpack. Here are some variables that we have to initialize for some time tracking. And yeah, so this is the most important while loop, or like the endless loop, in which we have several things that we take into account. First, we have this here. And this looks like one simple line of code, but because all of this handling of the received packets is in this function. So this if statement basically just looks if there is a byte in the FIFO. And if so, there's a signal detected, and we can perform our task and handle this message. And that's what this function is for. And this statement here just looks at a deadline. And if the deadline is passed and there are still some messages in our backpack, that means a node hasn't been updated, and we'll just print out a warning. Okay, so editor boys here, and I have quite a bit of footage left, and this could be a 30-minute long video, but I don't really want to do that, and I don't really think that this would be a nice and digestible way. So I will just split this video in two parts. And yeah, with that said, I have now went through the fundamental low-level functionalities and started explaining the main loop. In the next episode, we'll get to how we enter a string or a message for a specific node in the console, and we will then enter the receive packets variable function and go into depth into that function. There we will really see how the handling of messages that are received is done and the different cases for the different message types. And we'll go into two protocols, or like two sub-protocols, one for the mule-to-mod communication and one for mule-to-mule communication. So if you want to see that part, I would recommend watching the second part that I will link up in this little box here. And yeah, I hope you found this very interesting, or at least a bit interesting. And yeah, if you did so, please consider liking this video and subscribing if you want to see more of my content and want to see the second part of this explanation video. And yeah, so as always, thank you very much for watching, and I'll see you guys in the next one. Bye!